Hello again, this is Mr. Underkoffler talking about the guided notes on negative exponents. Now, this is probably the first time that you've even seen anything regarding negative exponents, and so I want to start this lesson very differently from how I've started the other ones. I want to do a little discovery activity. So that way, instead of me just saying, this is what negative exponents do because I said so, I want you to be able to actually see how the math works. Now, you may use your calculator to assist you. Depending what kind of calculator you have will depend where your exponent key is located. If you look at the examples I've shown you here, I tried to choose 3 of the most common calculators that I've seen this school year. The Texas Instrument TI-30X2S, you're going to have the caret key. That will allow you to take a number to any power that you want. If you have the TI-30XA that I have shown here in the middle of this slide, then you're looking for the y to the x key. So if I want to take 8 to the 3rd power, I punch in 8, then hit the y to the x key, then punch in the 3 for the 3rd power, and then hit equals, and it will give me the answer of 8 to the 3rd power. Casio owners, depending which kind of Casio you have, some of you will have the caret key. Others of you might have a key similar to the TI-30XA in the middle here. Instead of y to the x, you might have x to the y. So that's a possibility of how your exponent key might end up working. So back to the opening set of examples, and this is already 100% typed up for you if you have the guided notes in front of you. Let's go through this piece by piece so you can see how this is all going to play out. 8 to the 3rd power is 8 times 8 times 8. That would give you 512. 8 to the 2nd power is 64. 8 to the 1st power is 8. 8 to the 0 power is actually 1. 8 to the negative 1st power, if you use your calculator, you are going to get this decimal, which is 0.125. Now, in fraction form, that is 125 thousandths. That reduces, and remember, you have a fraction key in your calculator that will reduce fractions for you. That reduces to 1/8. That is the same as 1 over 8 to the 1st power. Now, you probably have no idea why I'm showing it that way. There is a reason. You're going to see it as I show you the next 2 examples. 8 to the negative 2nd power. Using your calculator, you're going to get this lovely long decimal. That is the same as 15,625 over 1 million, and that reduces to 1 over 64. Now, that is the same as 1 over 8 to the 2nd. Let's look at the last one. 8 to the negative 3rd is this lovely long decimal, which is the same as this lovely fraction. That's a lot of crazy zeros in that denominator. That reduces to 1 over 512. And some of you might kind of anticipate what the next thing is that I'm going to show if you're following the pattern here. That would be the same as 1 over 8 to the 3rd. Now, I would like for you to do the next 2 examples that I have for you, set up for you on the guided notes. The first one is 4 to different powers. The one after that is 10 to different powers. Please fill those pieces out. I have definitely guided you through some of this. Fill out the pieces, hit pause so you can do this on your own, then hit play so that way you can see the answers. All right, I hope you've done these problems on your own. I am now going to reveal the answers to you. 4 to the 3rd is 64. 4 to the 2nd, 16. 4 to the 1st is 4. 4 to the 0, I think I already have this filled out for you. It is equal to 1. 4 to the negative 1st is in decimal form 0.25. That is the same as 25 over 100, which reduces to 1/4, which is also the same as 1 over 4 to the 1st. 4 to the negative 2nd is 0.0625, which is 625 10,000ths. That reduces to 1/16, which is the same as 1 over 4 to the 2nd. 4 to the negative 3rd is 0.015625, which is the same as 15,625 over 1 million, which reduces to 1 over 64. That is the same as the fraction of 1 in the numerator over 4 to the third power. The next set of examples, powers of 10. 10 to the third is 1,000. 10 to the second is 100. 10 to the first is 10. You might notice a 0 keeps getting knocked off. That's one of the cool things with patterns of powers of 10. 10 to the 0 is 1. 10 to the negative first is 0.1, which is also known as the fraction 1/10, which is the same as the fraction of 1 in the numerator over 10 to the first power. 10 to the negative second is 0.01, which is the fraction 1/100th, which is 1 over 10 to the second power. And lastly, we have 10 to the negative third power, which is 0.001, also known as 1 over 1,000, which is 1 over 10 to the power of 3. I believe at this point you could probably start making some conclusions, which I have here at the bottom of the first page of your guided notes. The first one I've already done for you. 8 to the negative fourth power would be the same as the fraction 1 over 8 to the fourth. 4 to the negative 4, let's do this one together, is the same as the fraction 1 in the numerator over 4 to the positive fourth power. Next one, let's do it together. 10 to the negative fourth is the same as 1 over 10 to the fourth. Now, do the next set of examples on your own. I've already drawn the fraction bars for you. You need to fill out the numerator and fill out the denominator based on the patterns that you hopefully have been recognizing. So hit pause, do this last set of examples on the bottom of the first page on your own, then hit play when you're ready for me to go over the answers. All right, I hope you've done these problems on your own. 6 to the negative fourth. The numerator is going to be 1 over the denominator of 6 to the fourth. Notice the denominator no longer has a negative exponent. You should have recognized this as you were looking at the patterns from the problems we have previously been doing. 12 to the negative second is 1 in the numerator over 12 to the positive second power. N to the negative fourth is 1 in the numerator over n to the positive fourth power. Y to the negative 13th is 1 over y to the positive 13th power. Now, I threw a curveball at you here with these last two examples, but I was a little nice on the second to last one. 19 times x to the negative 6th power. Notice the 19 ends up staying in the numerator of the fraction. Why does it not go in the denominator? Because this really means 19 times x to the negative 6, which means only the x is being taken to the negative 6, not the 19. That's why only the x ends up in the denominator to the positive 6th power, not the 19. The 19 is not being taken to the negative 6, only the x, because order of operations says that exponents get done before multiplication. And since this means 19 times x to the negative 6, you would do the x to the negative 6 first, making it go in the denominator. The 19 ends up staying in the numerator. I'm actually going to show you another example like that on the next page. So if you're a little confused about that, it will be clarified for you on the next page. The last example is going backwards from all the other problems. I first give you the fraction 1 over w to the 7th. And I'm saying that's going to equal w to what power? Hopefully you were able to figure this out, because this is just going backwards from the other examples. This would be w to the negative 7th power. All right, let's turn the page. At this point, you should not need a calculator to be used anymore. It did serve its purpose to do the discovery portion of this lesson, but now that we are no longer in the discovery portion, you should not need a calculator anymore. Do this page without a calculator. Problem number 1, I will do for you. Follow along. 7 to the negative 2nd power would be, now forgive me, I forgot to read the directions. Write each expression using a positive exponent. So problem number 1, What could I write that would equal 7 to the negative second power, where I end up using a positive exponent? Well, use what you learned from the first page. This is the same as the fraction with a numerator of 1 over a denominator of 7 to the positive second power. That's what we just learned happens with negative exponents based on the discovery lesson that we did on the first page. I will also do number 2 with you. Negative 16, notice it's in parentheses to the negative fourth power. That is going to be the same as 1 over negative 16 still in parentheses. These parentheses matter. To the fourth power outside of parentheses. If you don't believe me that the parentheses matter, you could try this in your calculator without parentheses and then try it with parentheses, both times with the power being outside of the parentheses, and you will get different answers. One of them will be a negative answer, the other will be a positive answer, proving to you these parentheses actually do matter. All right, with that being said, try 3, 4, and 5 on your own. So hit pause right now, try 3, 4, and 5 on your own, then hit play when you're ready for me to go over the answers. All right, I hope you've done these problems on your own. Problem number 3 is going to be 1 over n to the 21st power. Problem number 4, 1 over c to the 39th power. Problem number 5, now this is a little trickier, and I kind of gave you a problem like this on the first page. What is actually being taken to the negative 8th power? It is only the x. How do I know? Because order of operations says that exponents gets done before multiplication. So that multiplying by 4, you actually need to deal with it after you've taken care of the x to the negative 8th. X to the negative 8th is the same as 1 over x to the 8th. So what do I do with the 4? The 4, like I already said, is not being taken to the negative 8th power. But notice the x to the negative 8 ends up becoming a fraction, 1 over x to the 8th. So as you remember earlier, it's kind of nice to have a fraction times a fraction. 4 written as a fraction is the same as 4 over 1. That is true with any whole number. It'd be the same as that whole number over 1. So if I multiply the numerators together, 4 times 1, that gives me a numerator of 4. Multiply the denominators together, 1 times x to the 8th, that gives you x to the 8th. And that is a detailed explanation, hopefully detailed enough for you, as to why the 4 ends up staying in the numerator, but the x to the 8th ends up in the denominator. Next set of examples. The directions have changed. It says write each fraction as an expression using a negative exponent other than negative 1. I will do number 6 and number 7 for you. Number 6, 1 over negative 32 in parentheses to the 6th power. That would be equivalent to negative 32 in parentheses to the negative 6th power. Here's a hint. I'm basically just doing what I did on 1 through 5, but we're going the other way. We're going backwards. Problem number 7. We have 1 over 51 to the 7th. That would be the same as 51 taken to the negative 7th power. All right, do 8 and 9 on your own. You might feel comfortable doing 10 and 11 on your own as well. I'll leave that up to you. So hit pause, do these problems on your own, then hit play. I will go over them. All right, I hope you've done at least 8 and 9 on your own, possibly also 10 and 11. Number 8 is going to be y to the negative 3rd. Number 9 is going to be k to the negative 44th power. Now, 10 and 11 are a little interesting. Remember the directions said that you are supposed to write these with a negative exponent other than negative 1. Forgive my poor highlighting job there. So if you are going to write number 10 as 25 to the negative 1 power, you can't, because the directions said not to do it with an exponent of negative 1. So you're going to have to get creative. Here's a hint. It's going to be a different base other than 25. Something else being taken to a negative exponent. So with that hint, try 10 and 11 on your own if you haven't already, and then hit play whenever you're ready for me to go over them. All right, I hope you already hit pause and did 10 and 11 on your own. Here's number 10. You can't do 25 to the negative first power because the directions said you couldn't. So what else could I take to a power to get 1 over 25? Here it is, 5 to the negative second power. Think about this. 5 to the positive second would be 5 times 5, which is 25. So to get the fraction of 1 over 25, it's going to be 5 to the negative second power. Now, if that just gave you an aha moment, then now maybe you can do number 11 on your own if you were totally wrong on number 10. So now try number 11 on your own if you haven't already. If you need to fix it, then hit play when you're ready for me to reveal the possible answers. All right, number 11. Hopefully you already tried it on your own or redid it on your own if you had to. This actually has 3 possible answers. 8 to the negative second, 4 to the negative third, or 2 to the negative 6. All 3 of those expressions would be equivalent to the fraction of 1 over 64. All right. Little side note that I have for you here on the middle of the second page, which I have here at the top of the slide. Whenever you evaluate, which means find the value of the problem, or when you simplify, which means make it as simple as you possibly can, whenever you do those kind of directions with an expression, the final answer may not contain a negative exponent. You probably never knew that before because I never had to teach you that before because we never dealt with negative exponents before. But now we are dealing with negative exponents. So take a look at these directions. It says evaluate, which means find the final answer or the final value of the problem. And as I just told you, whenever you have the words evaluate or simplify in your directions, the final answer is not allowed to contain a negative exponent. I'm going to go ahead and do problem number 12 for you. But before we do it, let's finish reading the directions. It says, evaluate each expression if C equals 6, K equals negative 3, and W equals 4. Guys, you always got to read directions. If you wouldn't read the directions, you wouldn't have a clue how to do these problems. Problem number 12, W to the negative fourth. Well, what is W? Look at the directions. It is 4. So this is going to substitute the 4 in for the W, and you will get 4 to the negative 4. Now, are we done? No, we are not. Remember what I just taught you a couple minutes ago. When the directions say evaluate, the final answer may not contain a negative exponent. So use what you've learned on these guided notes. What's another way of writing 4 to the negative fourth power? It is equivalent to the fraction with a numerator of 1 and the denominator would be 4 to the positive fourth power. That's what we've been learning on this entire packet of guided notes. Now we can go even further. What is 4 to the fourth power? That would be 4 times 4 times 4 times 4. I'm not going to fault you if you use a calculator for this. Although, actually, I am going to fault you. Forgive me. Funny, I told you not to use the calculator on this. So 4 times 4 is 16. 16 times 16 would give you 256. You're welcome. I did this problem for you. Remember, I said we were going to do this one together. So that makes this final answer 1 over 256. Now, if you would like, I will do number 13 for you as well. If you instead want to hit pause and do all the rest of these on your own, fine with me. But for those of you who want, I'm going to go ahead and do number 13. Feel free to follow along. 5 to the K power. Well, what is K? K is negative 3. We see that in the directions. What do I do now? 5 to the negative third is the same as 1 over 5 to the third. Now I just got to figure out what 5 to the third is. 5 to the third would be 5 times 5 times 5, which would be 5 times 5 is 25 times another 5 would be 25 times 5. Think quarters. 5 quarters is $1.25. So that would make this 1 over 125. All right. If you have not done 14 and 15 and 16 on your own, now's the time to definitely hit pause and do those 3 problems on your own. All right. I hope you have already done 14, 15, and 16 on your own. I'm now going to go over them. Number 14, substitute negative 3 in parentheses taken to the negative second power. I actually taught you earlier this school year that anytime your base is a negative number and you take it to a power, it has to be written in parentheses. I don't know if you still have those guided notes or not, but that's why I'm using parentheses. Anytime you have a negative number taken to a power, that negative number for the base, in this case -3, must be written in parentheses. You might have seen that on some of the earlier examples of these guided notes. All right, if you didn't have the parentheses, throw them on there now and fix this as I go over it. This next step is going to be 1 over -3, still in parentheses, taken to the positive second power. Now, what does that mean? That means the denominator is -3 times -3. A negative times a negative would be a positive. And that's why it ends up being 1 over 9. All right, number 15. And 16, they look like they're the same problem, but they're not. Think order of operations. Parentheses would be done first. But if there's not parentheses, then exponents would be done first. So let's compare and contrast 15 and 16 together. Number 15's first step is substitution. Number 16's first step is substitution. But 16 has parentheses. 15 is not. That's going to totally change how these problems finish. Because when there's parentheses, you do what's inside first. So on number 16, you would take 2 times 6 first because it's in parentheses. That gives you 12. But on number 15, we do not have parentheses. So you will not do 2 times 6 first because order of operations would say you would do exponents before you would multiply by the 2. So you have to deal with the 6 to the -2, which is 1 over 6 to the second. As I showed you on an earlier example, that 2 is not being taken to the -2nd power. That whole number of 2 is 2 over 1 when you write it in fraction form. This would then become numerator times numerator gives you 2 times 1, which would be, oh, forgive me, my bad. Let me follow order of operations. 6 to the 2nd power would be 36. Forgive me for forgetting. I need to finish the exponents before I do the multiplication. Number 16's next step would be 1 over 12 to the second. Let's now finish 15. Numerator times numerator is 2 times 1, which is 2. And the denominator is 1 times 36, which is 36. That fraction can reduce to the value of 1 over 18 because both the numerator and the denominator were divisible by 2. Let's finish up 16. 12 to the 2nd power means 12 times 12, which is 144. So the final answer is 1 over 140. Last two problems, number 17 and 18. Try these on your own. Hit pause to do that, then hit play for me to go over them. All right, I hope you've done these problems on your own. Number 17, the slowest moving fish is a seahorse. It swims at a maximum speed of 0.0001 miles per minute. Write this speed as a fraction and as a power of 10. All right, if I write this as a fraction, that would be 1 over 10,000, which is the same as 1 over 10 to the 4th. Now, to write that as a power of 10, think about what we just learned, that would be 10 to the -4th power. And there's the two answers that this problem is asking for, the fraction form and the form as a power of 10. Number 18, Martha's book report was typed on a few pages. The width of the pages totaled 1/49th of an inch. Write this width as an expression with a negative exponent other than -1. Now, this is kind of like what I was telling you before. You cannot write this as 49 to the -1st power because they just told you not to do it with a negative exponent of -1. So, you need to realize that 49 is the same as 7 to the 2nd, which makes the fraction 1 over 7 to the 2nd instead of 1 over 49. And then that would be equivalent to 7 to the -2nd power. And that is the last two problems of the guided notes on negative exponents. We'll see you next time.